is the derivative what? Negative. All right, so we have a lot to do here, don't we? This is saying, hey, take a look at this function. Tell me where the function's going up. Tell me where it's going down. Tell me where we have any local maximums or minimums. Okay, here's the procedure. You ready for the steps? First step for this problem. Find the critical numbers. Okay, let's find the critical numbers because those are going to be places where the derivative is 0, right? Also where the derivative is undefined. So to do this, what do we do? Take the derivative, right? Okay, take the derivative. And what is that derivative? 3x squared minus 12, right? Now what? Solve for x. So that's going to be part 1. I understand we're already doing part 1, but this is like a sub part here, right? Part 1 is to take the derivative, set it equal to 0. So take 3x squared minus 12, set it equal to 0. Move 12 over, divide by 3. X squared is 4. Square root. What do we get? Plus or minus 2, right? There's 2 answers. I take square root here, we get 2 answers. So how many critical numbers do we have so far? Just 2, right? Now, second step, where's the derivative undefined? All right, so you asked for it, right? Where's it undefined, sir? Where's this derivative undefined? Or I should ask, is it undefined? So what are you thinking? If I'm asking you where that's undefined, what are you thinking? Okay, it can't be, right? There's no problems here, right? Do you see division by, do you see a fraction? No. Do you see a square root? No. Okay, so if you don't see those, then this can't happen, okay? It's pretty much that simple. We don't see a fraction, we don't see a square root, we don't have to worry about that. All right, so we have 2 critical numbers, right? Now, the next step is something we have not done yet, all right? So let's see if I can't make this make sense. I'm going to draw a number line. This is the second step. I'm going to do a number line. And once I do it, I'm going to try and explain what my thinking is here. I drew a number line, and notice the 2 points I put on that number line. Where did I get those 2 points from? Yeah, those are my critical numbers. So what I've done is I've put my critical numbers on a number line, right? Now, the reason I've done this is because I want to know what's happening to the left of this. Is my function going up over here or down? And then between these two, I'd like to know, is my function going up or down? And then over here, I'd like to know, is my function going up or down? Does that make sense? If it does this, if it goes up and then it goes down, then what's happening at -2? If it goes up and then it goes down, what's happening at -2? What do we have here? Oh, you're done. You're up. If our function goes up here, then down, then what's happening at -2? Would we have a local maximum or a local minimum? Max, right? Top of the hill, your maximum, right? If it went down and then it went up, minimum, right? Okay? So how do we actually determine that? Well, what we do, it's actually pretty clever, okay? We know what the derivative is, right? This tells us everything about whether or not the function's going up or down, right? This tells us everything about whether or not it's going up and down, up or down. So what I'm going to do is I'm just going to pick 3 random points, 1 from each of these intervals. So you see how these critical numbers, -2 and 2, split our number line up into 3 sections? Do you see it's a pretty natural partition of the number line? Now I get to pick any number I want over here. So what would you like? -1 would be over here. Careful. Remember, zero's in the middle here, right? So this will be like -1, -2, -3. Okay, so I'm putting -3 here. Notice I'm going to circle that number because it's a special number. Your next number in here, please.
3.
In here.
Oh. 1.
1 would work, 0 would work. You're going to pick 1, fine. And then you want one over here? What do you want? 3. Okay, could you have picked 4? Okay, yes, you could have picked any number there. Now, what do we do with those numbers? Plug them into what?
The top one.
That top one? That top one? What do we call that? The derivative, right? Why are we plugging these numbers into the derivative? Because the derivative tells us everything about up and down, right? Everything about up and down. So let's try this. Let's plug in. So that's the third step. Third step is plug. Can we go back here where I said number line? Put number line and test points. Because that's what we did. We picked these points, right? And we're going to call these test points. So we do a number line, we do our test points, and then third step is to actually plug test points into, and you told me what, into the what? Into F prime, all right? Do not plug it into F. Plug it into F prime. All right, so I get to plug those numbers into here. So let me try the -3 first. F prime of -3. What happens? 3 times -3 squared minus 12. So be careful, you have to square the -3 first, right? All right. Shh. You're up. You get to tell us what that is. And if not, then we're all going to get on our phones. We're going to make fun of you. We're going to get on to whatever apps you're on, and we're just all going to make fun of you. All right? Take your time, no pressure.
-3 squared.
Yep.
9.
9.
And then times 3 is 27.
27.
And then minus 12.
15. Yes?
Yep.
What do we really care about that answer? What do we care? All we care about is that it's positive. Why? Because that tells me that the derivative here is positive, right? That means that when I'm over here, my derivative is positive. Right? Over here, my derivative is positive. What does that mean my function is doing over here? It's going up. So if you wanted to draw a picture, the graph, well, I'm not even going to draw a picture. I'm just going to say F is going up. Is that all right? Notice that notation. The derivative is positive over here because it's 15 and 15 is a positive number. That means the original function is going up over here. Now what? Plug in the second point. Now, it was 1 was chosen for us, right? But we could have picked any number in here. 1 was chosen. So we plug 1 into here, and you have it yet? Okay, what is F prime of 1? -9. And all that matters is that it's negative, right? So we know that in here, doesn't matter if it's here, it's the whole region. We're guaranteed. That's kind of a nice thing about it. We know that my derivative is negative here. And what does that mean my original function is doing here? My original function is decreasing, going down, right? And finally, we plug in the third test point, F prime of 3. And when we plug that in, don't we get 15 again? We get 15 again, because when you square the 3 and -3, the exact same thing happens. So that means my derivative is positive, which means my function is going up, not the derivative. My function is going up. All right, we're ready. We're ready with this little picture. You see this nice picture we put together here? We're ready to answer all the questions. Any questions on any of this build up to this, though? Okay, here we go. Let's answer it. So here's my answer. That was all my work. Okay, here's my answer. F is increasing Okay, where is f increasing? Everywhere over here, right? Forever this way, right? To the left of -2, my function's going up, right? So if I were to be reading this, like this is what the graph would look like. We know that this way, like if we read it from left to right like a book, we're going up the whole time, right? That's happening all the way until we get to -2, right? And then it starts going down. But then over here it starts going up again, right? So the way we say that is all the numbers over here forever to the left of -2, and then all the numbers over here forever to the right of 2. Here's the way we write that down. -infinity to -2 union 2 to infinity. Now, have you ever seen that before? This is called interval notation. This is saying if we are to the left of -2, that's from -2 that way forever. Union means like also. Also, if we are to the right of 2, that's from 2 on this way forever. Then our function is going up. Where is our function decreasing? Yeah, only between -2 and 2. So we say that with parenthesis -2, 2. That's just between here and here. Do we have any local maxes? And do we have any local mins? Who said that? What, who? What? Okay, so at 2 and -2, we've got things happening here. So what's happening in -2? Is it a max or a min?
Oh, max.
It's a max, right? So we go up, then down, right? That means we have a maximum at -2 because we go up and then down. Now, you have to be careful because the actual local maximum is the value of the original function at -2. We have to plug this -2 into the original function which I erased. Right? It's some number. I've erased the function. But whatever this number is your answer. That's your maximum value locally. Now what about a local minimum? We have one, right? That's happening at 2, right? Because we go down then up. Down then up is a minimum. F of 2, you plug it into the original function, not to the derivative, and you get a number here, and that's your answer. Okay. I'm gonna see how you do on the homework with this. Before I send you off to do that, I know we're already out of time. I want you to understand they use a little bit, their language is a little bit different in the book. In the book, they ask you for, in the homework, they're going to say to you, find local extrema. Yeah, they are going to say, find local extrema. And I didn't have a chance to write that down. Local extrema. What this means is find your local min and your local max. Okay, it's one word that encompasses both. So if they ask for the local extrema, they want you to find both of these. All right? So on your homework, I'm going to read you what it says. Find where the function is increasing and decreasing in the local extrema. That's the exact same question I just asked you. Then they also ask you on some problems later to do the same thing. Find out where it's increasing and decreasing. And then they ask you to sketch the function. Skip the sketching. Don't worry about the sketching. All right?
We're doing section 12.1?
This is 12.1. We didn't get to 12.2. All right, so next class we're going to do something. I think what I'm going to do is what a buddy of mine does. And that's, he has these things. He has these, what are these, tongue depressors? And everyone writes their name on them. And we put them in a jar. And then you just get chosen during class. And just, as you go through the class, just choose the whole class. So I'm just going to be calling on y'all. Because you apparently want that, yes? Yes, of course you do. Do your homework.
Just one question.
Yes.